Okay, class, in this lesson 6.1 we're going to do law of sines, where we are going to use law of sines to solve oblique triangles. And remember, oblique triangles are ones that aren't special at all, and most importantly, these are not right triangles. Everything that we've been doing so far this year had to do specifically for right triangles, so SOHCAHTOA and all that stuff in the unit circle all apply to right triangles. So we cannot use all of that stuff when we're solving these oblique triangles. However, this first one called the law of sines, which is here in the box, this is the actual formula that you will need to memorize. This is actually comes from SOHCAHTOA. So here we have just an oblique triangle. And if I draw in a height, I call this H, and if this is my angle A, now in this section the angles are capital letters and then the sides are lowercase letters, specifically with the capital letter A and its opposite side A, the capital letter B for the angle and its opposite side lower b, and then the C's, they're opposite each other, so they'll always be named in this way in this section. Okay, so if I have the height here and I have an angle here, and I only look at the left hand triangle here, so looking at this triangle here, and since that is a right triangle because I drew in the altitude here, the perpendicular, I can use SOHCAHTOA on this. I know that the sine of angle A, using SOHCAHTOA, it's opposite over hypotenuse. Okay, so taking this information and doing the same thing with angle C, I know that angle C says the sine of angle C is opposite over hypotenuse, so H over A. And I could do a very similar thing with angle B. Of course, with angle B, I'd have to have a different altitude drawn in, but I could get a very similar thing. Now, if I take both of these and I solve for H, this first one I get H is C sine A, and the second one I get little a sine of big C, and both of those equal H. So if they both equal H, they equal each other, so these equal each other. So I have C sine A equals A sine C. If I divide both sides by A, they cancel on the right hand side. So I'm just going to erase it. And I'm going to divide both sides by C so that on the left hand side they cancel. So I'm just going to erase them. And voila, here we have those two portions of the law of sines. Of course, if I did a similar thing with B, I would get the same sort of relationship. Okay, so this is where that came from. In the end, you don't really have to understand fully where the law of sines come from, but it does help you to remember it. Okay. So here we have a oblique triangle, and what we're going to do is we're just going to set this up. I have A, B, and C. So A is 98 degrees. Little a is 10 and little b is 3. Remember, assign the angles capital letters and their sides opposite the corresponding side. So I plugged in the givens, and I need to solve the triangle, and solve means find all angles and sides. Okay, now the Pythagorean theorem works for right triangles, so we can't use the Pythagorean theorem to find the third side. So we are going to use the law of sines, and we're just going to set up the proportions. The law of sines says sine of A over A equals the sine of B over B, and that equals the sine of C over C. Oops. Okay, so I know some things about A, and I need to find angle B. Now these are in degrees, so we need to make sure that we're in degree mode on our calculator. Please follow along with your calculator just to make sure that you're comfortable using it so you can ask questions in class if you're not getting the same answers as I do. So I'm going to find for angle, I want angle B, and I know about the pair for A's. So I'm going to use these two pieces. You should use two of these pieces at any point in time to solve. Okay, since I'm going to solve for the angle, it's easiest if you put the unknown in the numerator. But of course you could write all of these as reverse fractions, and I'll show you. So sine of angle A is 98 degrees over little a. 10 is the sine of b over little b is 3. So you just need to solve this. So in order to solve this, I'm going to multiply both sides by 3 so that they cancel. And sine of b, which I'm left with, so I'm just switching it around, is 3 sine of 98 degrees over 10. 98 degrees is certainly not on the unit circle, so this whole statement you would just put into your calculator. And then you would find out what sine of b is. Sine of b is approximately equal to 0.297. What is it? 0.297. And some other stuff. It's still in my calculator to solve for b. This is the inverse of sine of 0.297 and all that stuff that's in my calculator. And I want to keep the number in the calculator. So I'm going to use the unrounded number on the calculator here. And I'm going to round once and only once at the end. Okay, so I get 17.2823, and I want to convert this to DMS. So we get angle B is 17 degrees, 16 minutes, 56.39 seconds. And that's what we get for angle B. So remember, to convert to DMS, you go to the angle menu, and then you choose the option 2DMS. Okay, so that found us angle B. So we know that angle B is 17 degrees. We know angle A is 98 degrees. So we can find angle C because we know that the sum of all the angles is 180 degrees. So C is 180 degrees minus A minus B. B is in your calculator right now, so the shortest thing to do to find angle C is to just type in 180 minus 98 minus answer, and we're going to convert it to DMS. You should get 64 degrees, 43 minutes, 3.61 seconds. So make sure you're getting these answers exactly as I'm getting them. If not, please ask in class. Okay, so now we found all the angles. So now what's left is side C. So I'm going to find side C. And so now I'm going to flip my proportions. C over sine of C is, now we can use either A or B at this time. Quite frankly, A is nicer to type in than B, so I'm going to choose to use A. So it's A over sine of A. Now when you use your proportions, you need to make sure you keep your sides all on the same, like either all of them on the top or all of them on the bottom, and the angles all need to be on the top or all need to be on the bottom. Okay, so it's fine to flip it just as long as you flip both of them. Okay, so C over sine of this 64 degrees and some other stuff, which is in your calculator, so I'm just going to use that number exactly as it is in the calculator. So use the full number in the calculator, equals A, which is 10, over sine of A, which is 98 degrees. Okay, so if I just multiply both sides by this bottom part, which I will highlight, if I multiply both sides of the equation by that thing, then they will cancel on the left hand side. So this is says sine of 64 degrees and plugging it into the calculator, you get that C is 9.1310. Okay, is it going to show up? Okay, there we go. So, if you have questions about using your calculator to get the previous answer at all, please ask your teacher in class so that we can show you the shortcuts. So we've solved the triangle because we have found angle C, side C, and angle B. So we have all 6 parts of the triangle now. Okay, let's move on to the next question. 2 fire ranger towers lie on the east-west line and are 5 miles apart. There's a fire bearing with a bearing of north 27 degrees east from Tower 1 and a bearing from Tower 2. How far is the fire from Tower 1? Okay, so I'm going to have 2 fire towers. I'm just going to call these 2 triangles. Fire 1, or Tower 1 and Tower 2, and I'm going to call this the fire up here. So the fire has a bearing of 27 degrees northeast. So between north and east, so remember it's never eat soggy waffles for northeast, south, and west. Between north and east, it's 27 degrees from Tower 1 to the fire, and a bearing of north 32 degrees west from Tower 2. So from Tower 2, so I'm starting at Tower 2. So from Tower 2, from north to west, there's a bearing of 32 degrees. Now, the axes we draw in for the north, south, east, west lines are perpendicular lines. So I know 27 degrees and this angle in here are complementary angles. So this angle is going to be 63 degrees, and likewise 58 degrees over here for Tower 2, because I wrote 58 plus 32 degrees is 90 degrees. So I have those. I of course know that the sum of the angles is 180 degrees, which can tell me that this third angle is 59 degrees. So what I want to know is how far the fire is from Tower 1, which means this side, which I can call X. And the law of sines, A over sine A is B over sine B, and so on. It essentially means the sine of an angle and its opposite side equals the sine of another angle and its opposite side. So these X and 2 are opposite from each other. Okay, and then the other one that I know something about is that the 2 fire towers are 5 miles apart between Tower 1 and Tower 2. They're 5 miles apart. So the 2 pairings I know are from Tower 2 and its opposite side X, and the fire 59 degrees and its opposite side 5. So I'm going to set my proportion. This unknown side over the sine of its opposite, 58 degrees, is 5 over the sine of 59 degrees. So remember the sines on one and then the side lengths on the other. So I'm going to multiply both sides by sine of 58 degrees so that they cancel, and I have X equals this thing that I just plugged directly into the calculator, 4.95, and then I'm going to answer the question in the form of a sentence, and I have that the fire is 4.95 miles from Tower 1. Okay, this next example is finding the area with the ASA case. And so there's 3 different formulas. Essentially, you use the one based on the the angle you're given. I am given, I say ASA, I mean SAS. Here is angle B, so I'm going to use this portion because that is the angle that I'm given, angle B. Okay, so using the middle formula, because I'm given angle B, I'm just going to plug in what I know, plug it into the calculator. Okay, so plugging this directly into the calculator, I get 692.82, wrote it in a complete sentence. But do note that sine of 120 is on the unit circle. So if I plug that into the unit circle and simplify those numbers, I can get the exact answer here. Okay, so that is all for the law of sines, so move on next to the law of cosines video. Have a good night.